Hello and welcome to this tutorial on product of prime factors. It is something that we do using factor trees. So before we go into how we do this, let's look at the language here. So the language here, we need to know what all of these words mean. So product in mathematics means multiplication. So for example, the product of 3 and 4, the product of 3 and 4 is 12. Okay, the product means multiplication, the result of multiplication. Prime numbers, they're numbers with exactly 2 factors. So for example, 2, 3, 5, 7, 11, those are the first 5 prime numbers. They can only be divided by 1 themselves. Hopefully you guys have heard of those before. And then factors. Factors are numbers that divide into a number. So if we're looking for prime factors, we're looking for these sorts of numbers dividing into a larger number. Let's go into it. It is actually quite a straightforward topic. I think it's quite a nice topic. And so here's an example. We're going to write 120 as a product of prime factors. And we do that with a factor tree. It looks a little bit like a tree when we finished. And we find a factor pair. Okay? So we want 2 numbers that multiply together to make 120. I like to divide by 2 first, because it's the smallest number that is going to be worth dividing here. So I'm going to go 2 times 60. Now, the key to this is if you spot a prime number, and let's just remind ourselves, 2, 3, 5, 7, 11, 13, there are obviously plenty more. If you see a prime number, put a circle around it and say, that branch is finished, because now I can only divide by 2 and 1, and it would be 2 and 1, 2 and 1 people. The 60 we're going to divide and find a factor pair for that. I'm going to go with 2 again. So let's divide by 2, multiplied by 30 makes 60. This is prime, so I put a circle around it. 30, does it divide by 2 again? Let's try that one. Put a circle around that, times 15. 15 doesn't divide by 2, divides by 3 5 times. 3 times 5. And 3 and 5, they are prime numbers. And so there is my finished factor tree. So 120 is a product of prime factors. We can write as 2 times by 2 times by 2 times by 3 times by 5. That is 120 written as a product of prime factors. One little thing I want to add to that is this is a correct answer. There is nothing wrong with that. But we can simplify it a bit and write it in what we call index form, or write it with powers. So instead of 2 times 2 times 2, I could write that as 2 cubed. 2 times by itself 3 times, then by 3, and then by 5. So sometimes you'll want to write your answer in index form. It's a little bit tidier and a little bit of a more mathematical answer. Okay, here's one for you to try. I suggest you write 100, find some factor pairs, and pause this video now. So pause the video, and then I will go through the answers for this one now. So 100, we could do as 10 and 10 for a factor pair there. And that would divide into 2 and 5, 2 and 5. And we just need to make sure that we circle those prime numbers. And we get 2 times 2 times 5 times 5. I like to put these in order from smallest to largest. It's easier to compare them to other products of primes when we do that. And if we tidy that up, 2 squared times 5 squared. Okay. Now, in that example, I divided by 10 and 10 first. But what I could do is I could divide by 2 first, and then I would get 2 times 50. 50 divided by 2 is 25, and 25 is 5 times 5. It gets me to the same answer. It doesn't matter which method you use. You can divide by anything you want, any factor pair, you will still end up with the same answer. And in fact, I could even have divided by 5 and 20 first. So many, many different ways to solve them. They all get you to the same answer. So don't worry if you think, oh, should I have started with that? Here's another one to try. Try 54. So pause the video now, write it down, and get your factor tree going. Pause. Here is your answer. So we divide it down there. We get 2 times 3 times 3 times 3. And that gives us 2 times 3 times 3 times 3, which is 2 times 3 cubed. 2 times 3 times 3 times 3. And here's another one slightly trickier perhaps, 225. Now, the reason I think this one is slightly trickier is because that first step, 5 times 45, is not an easy one. If I look at the number 225, it ends in a 5, so I know it divides by 5. But I don't know how many 5s go into 25 off the top of my head, so you might need to do a little bit of short division or long division and just say 5s into 20, 5s into 2, and 0, carry the 2, 5s into 22, that's 4, remainder 2, 5s into 25 is 5. For some of the larger numbers, you are going to need to do a little bit of short division to get it going. All right, pause that, finish that one off yourselves. And once you've done that, here is your answer. Here we go. And it is 3 squared times 5 squared. All right, here is a little puzzle just to extend you at the end here. Give everybody a chance to pause the video now to see if you can have a go at this one, and then I'll go through the answer. So 5x squared equals 45. Can we use a factor tree to work out what x is? All right, pause the video. And here we go. So, if I want to know 5 times something squared, 5 times x squared, well, this actually looks a lot like that product of primes with the indexes. And so, what I'll do is I'll take 45 and I'll break it down with a factor tree. When I do that, I get 3 squared times 5. And if I've got 3 squared times 5, well, that means that the x here is 3. Because 5 times 3 squared equals 45. So that's a little bit of an extension one there just to get you thinking. But that's product of primes. It's quite a fun little topic. Thanks for listening.